Everyone. So today we are going to discuss the 2019 simple harmonic motion question. Okay. So what we are telling is the points O, A and B lie in that order. O, A, B lie in that order with O logarithms on a line of the greater slope of a smooth fixed plane inclined at an angle pi by 6 to the horizontal. Okay. The angle is 1. Such that OA is equal to A and AB is equal to 2A. So all these data have been marked in the diagram. Then you see one end of a light elastic string of natural length A and modulus of elasticity mg is attached to the point O. So one end is attached to the point O and the other end to a particle P of mass simple M. Okay? And the other end to a particle P of mass simple M. Okay, so we have given some data as you see. Natural length is A and modulus of elasticity is mg. So in bracket we know that natural length is A, modulus of elasticity is mg. And the other end of particle P of mass A. The string is pulled along the line OAB until the particle P reaches the point. Then the particle P is released from rest. That point is also really important. So what they are doing is they are pulling the string up to point B and releasing it from rest there. So at the point B, the velocity is what? 0. You see, the string is pulled along the line OAB until the particle P reaches the point B. Then the particle P is released from rest. Show that the equation of motion of P from B to A is given by. So they are asking to show the simple harmonic motion equation as what? X double dot plus G over A into X plus A by 2 is equal to 0. So we should show this. Okay. So let's see how to show. So what we are telling is now the natural length is A. See, this length is also A, natural length is A. So they are pulling the particle up to B and from B they are releasing it from rest. So it will oscillate like this. Okay. So we have to derive this equation. So I am considering a point like this. Okay, now you see, now normally when we are doing simple harmonic motion questions, this is 2019 now. So we initialize a length like this. Let's say this is a vertical simple harmonic motion. Okay, so if this is mg, okay, if the natural length is A. If the natural length is A, sometimes we measure the extension from this. We consider this as X. Sometimes we consider this as X. Okay? So this X can differ. Okay, sometimes they will give in the question where to take it, or else you can take which is convenient for this. Okay? So in this question, what they have given, you will see they have given. They are A, P is X. Okay? So this is particle P. So from A only we are measuring the distance. Okay, so AP is X. Okay, so we have to derive this equation. Which one? X double dot plus G over A into X plus A by 2 is equal to 0. First of all, let's mark what are the forces acting. Okay, they will act in the downward direction. So mg. Okay, so there is a string. There will be a tension. Okay, so we are going to write down the simple harmonic motion. Now they have mentioned, you can see, AP is equal to X. Okay, we are measuring the distance in this direction. So its velocity is in this direction, X dot. Then its acceleration will be in this direction, X double dot. Now we are to show this equation. That is the first question to show that the equation of motion of P from B to A is given by X double dot plus G over A into X plus A by 2 is equal to what? 0. Okay. Now we are going to apply F is equal to M. So when you apply F is equal to M, you have to consider point. In which direction you have to apply? The direction is really important when you are applying in maths. In part A question also, work power, energy and those questions. If you are applying up the inclined plane, put in that direction. Downward direction means the direction is important. Okay. So here we can apply in this direction, we can apply F equal to M. Or else we can apply this direction F equal to M. But it is good if you apply F is equivalent to MA in this direction. Always apply F is equivalent to MA in the direction of acceleration. In other direction also you can apply. I think any problem. Okay. First let's apply in this direction here. Okay. If I apply F equal MA in this direction, what we have? Minus T. You see? Minus T minus. This is mg cos pi by 6. So in this direction, mg sin pi by 6. mg sin pi by 6 is equal to m into acceleration is x double dot. See, x double dot is in this direction, so consider direction, it is plus. If you apply F is equivalent to m in this direction also, nothing any problem. See, t plus mg sin pi by 6 will be. See, in this direction, both the forces acting now. So m into, we have to put minus x double dot. Sometimes you may forget this minus. Therefore, it is always safe to apply F is equivalent to ma in the direction of what? Acceleration. Okay. So how do you write the tension? So already we know tension is equal to what? Modulus of elasticity mg divided by natural length is v into extension is what? X. Therefore you can put that minus mg x over a minus mg sin 30 is half minus mg by 2. That is m into x double dot. Okay, so this m get cancelled. Okay, so in the answer you see we have g over a. Then I can take this minus g over a out. Then what will I get? X and set it here. Okay, so here you see here plus. Then only minus g we already took. So there should be a here by 2. That is equivalent to x double dot. Then what we get? X double dot plus g over a into x plus a by 2, that is equivalent to 0. So this is the equation of what? Simple harmonic motion they asked to show. We showed it. Okay. So this is easy. Okay, this part of the question is easy. So next the question what they are telling is, let y is equivalent to x plus a by 2. Okay. So they are telling y is equivalent to x plus a by 2. Okay. Then they are asking, rewrite the above equation of motion in the form y double dot plus omega squared y is equal to 0. You have to write it in which form? Y double dot plus omega squared y is equal to 0. Where omega they are given. Okay. So what they are telling, it is x plus a by 2 is equal to 1. So why they are asking to transform this equation to this equation means, normally simple harmonic motion equation is that x double dot is equal to minus omega squared into x. So normal simple harmonic motion equation is x double dot is equal to minus omega squared into x. So this x plus a by 2 is a bit long name, so we can short it down. We can get it to that point. So in order to more modify it, they are asking to transform into this form. That is the reason they are doing this. Okay. So they are told what y is equal to x plus a by 2. And to show it in the form y double dot plus omega squared y is equal to 0. Okay. Now consider this equation. So what is this equation? X double dot plus g over a into x plus a by 2 is equal to 0. Okay. Here, now you see, if I put, instead of x plus a by 2, if I put y, nothing any problem. Then are you going to keep x double dot by both the equation? No. By means I translate everything in terms of. So instead of x double dot, what I can write? So I have to go to x double dot here. So first I'll differentiate with respect to t, then what I get? Y dot is equal to x. Again differentiate with respect to t, then y double dot is equal to x double dot. So in the place of x double dot, what I can write? Y double dot plus g over a into, instead of x plus a by 2, I can write what? That is equal to 0. So what is they have given? You see, they have given omega is equal to square root of g over a. Then what is g over a? G over a will be omega square. Then what we can show? Then we can write it as y double dot plus omega squared y, that is equivalent to what? That is equivalent to 0. Okay. Okay. So this is what the first part. Okay. So let's move on to the next part. Okay. So next part what they are asking is find the center of the above simple harmonic motion using the formula. So they have given you a formula, you see. Y dot squared is equivalent to omega squared into c squared minus y squared. Okay. Find the center of the above simple harmonic motion using the above formula. So how do you find the center of the simple harmonic motion using the above formula? So you must know some details also. What they are telling? First, wait, no. The question they are telling is find the center of the above simple harmonic motion. That is, you have to find it using the equation. Okay, and using the formula. Y dot squared is equal to omega squared into c squared minus y squared. Find the amplitude c and the velocity of p when it reaches it. So already we found the simple harmonic motion. First part what we did, we proved x double dot plus g over a into x plus a by 2 is equal to 0. In second part what we did, we told y double dot plus omega squared y is equal to 0. Okay. So how do you find the center of the simple harmonic motion? One, you can use this equation or this equation. One, you can say y double dot is equal to 0. This implies y should be equal to 0. So center, where is it? Y is equal to 0. What we know? Y is equal to x plus a by 2. So y should be 0 means x should be what? Minus a by 2. Then the center of the above simple harmonic motion is x is measured in this direction. So opposite direction here. Okay? A by 2. Only the center. So center is here. Okay? Careful. But the question what they are telling, find the center of the above simple harmonic motion. So this is the equation of x double dot plus g over a into x plus a by 2 is equal to 0. That is y double dot plus omega squared y is equal to 0. So center means what we can say, y double dot is equal to 0, y is equal to 0. So we know y is equal to x plus a by 2. So when y is 0 means x is minus a by 2. So if x is measured in this direction, it is plus. So minus like so opposite direction, a by 2 only the center. Okay. So that is okay. And using the formula, find the amplitude c. Okay. First of all, they are asking amplitude c. You want to find the amplitude c. You know omega of this simple harmonic motion. What is omega? Omega is we have given square root of g over a. Then omega squared is equal to g over a. So we know the omega. If you want to find the center of the above simple harmonic motion, I should know y dot and y. So in any place, I should know its velocity. So y dot and measure easily. No? You see, y is equal to x plus a by 2. So distance is, so I can put any distance. So we only know the velocity. That is the key word they gave in the question. You see, I have denoted this. When the particle P is released from rest. See, particle P reaches. We are putting the particle P until the point D and we are releasing it from rest. So at the point B, its velocity is what? 0. Okay. So where velocity is 0 means that x is equivalent to 2a, the velocity is 0. You see? Then x is equivalent to 2a. Where x is equivalent to 2a, its velocity is 0. That means that x dot is equivalent to 0. You see, we already did that. X dot and y dot are same. So y dot also 0 in that position. So if x is equivalent to 2a, x is equivalent to 2a, what is 1? 2a plus a by 2. That is equivalent to what? 5a by 2. So y is equivalent to 5a by 2 we will get. Okay. Now we know y, we know y dot, we know omega. Therefore we can find what? The center of the what? The amplitude of the above simple harmonic motion. Center we already know, no? Yes. Center we found x is equal to minus a by 2. Okay. So what is y dot? Y dot is equal to 0. 0 is equal to omega square. That is equal to G over A into C square. This is the amplitude. Minus Y square is what? 5A by 2 whole thing square. Therefore, we can say C square is equal to 5A by 2 whole thing square. C is equal to 5A by 2. Amplitude greater than 0. Therefore, now we found the amplitude of the above simple harmonic motion. Then next part that they are asking is, see, using the same formula using again, find the amplitude C and the velocity of P when it reaches A. When P reaches A, they are asking to find its velocity using this equation. Okay. Now we have amplitude of the above simple harmonic motion. We know C. We know omega. If it is point A, we can measure Y. Then we can what? We can write Y dot. Okay? So we are going to use the same equation. They have directed us to use the same equation. So what is the equation? Y dot squared is equal to omega squared into C squared minus Y squared. So what is the asking? Find the velocity of P. When it reaches A, and find the velocity. So I don't know the velocity. Let the velocity be some V. So V squared is equal to omega squared. So omega is what? Square root of G over A. Then omega squared is equal to G over A. So amplitude we know 25A squared by 4 minus. Okay. So at A, X is equal to 0. See, X is measured from A. At this point, X is what? X is equal to 0. But we want Y. What is the relationship between Y and X? Y is equal to X plus A by 2. If X is equal to 0, what is Y? A by 2, that is square. Then A squared by 4. Then what you get? G over A to 24A squared divided by 4. So there is 6 here. Therefore, V is equal to square root of 6G. Okay? So V is equal to square root of 6Ga. That is the velocity of P when it reaches A. So with the velocity of P when it reaches A, we found as V is equal to square root of 6Ga. Then next part they are asking, show that the velocity of P when it reaches O. When it reaches O is given by what? Square root of 7Ga. So how do you find that velocity? When it reaches O, what is the velocity of P? Now you see, after passing A, see, its natural length is A. O is also A. So, after passing A, the strip slacks. That means what? Tension is 0. Then, no simple harmonic motion. Then from A to O, under gravity motion. So, under gravity motion means what? We can use these equations. Can remember now, V is equal to U plus AT, V squared is equal to U squared plus 2AS. These equations you can use. So what is the question they are asking is, show that the velocity of P when it reaches O. When it reaches O is square root of 7G. So how to show? I know the velocity at the point A. Okay. So I want to find the velocity at this point. So sometimes now you may have a confuse in this direction. You see, now X is measured in this way. Similarly, Y is also measured in this way. So if I tell, let the velocity at the point A be minus V. That is good. If you can tell like this, let the velocity at the point A, be minus V. That means in this direction minus V means if I square it, I will get V square V. Therefore, this 6GA is in this direction. You understand that this is square root of 6GA in this direction. So, you have to find the velocity at the point O. Therefore, from A to O, what type of motion? It is under gravity motion. Okay. So, what kind of equation we can use? Now, there are a lot of equations. One is V is equal to U plus AD. Other one is V square is equal to U square plus 2S. So, using the data only we can determine. Okay. See, this time is related with these things. We know the initial velocity. We know the distance. We have to find the final velocity. Then the most suitable equation is what? V squared is equal to U squared plus 2x. Therefore, we are going to apply the equation from A to O. Therefore, V squared is equal to the initial velocity is 6GA. Here, see. Now, when you are putting the acceleration, careful. This is along the slope. Don't put plus G or minus G. G cos what? This is 5 by 6. This is 5 by 3. G cos 60. Okay. So, this is plus 2. G cos 60 is half into distance is what? A into A. Therefore, this get cancelled. So, therefore, B squared is equal to 70. Therefore, V is equal to what? Square root of 70A, we can write it. Okay. Then, next part what they are asking. Show also that the time taken by P to move from B to O. So, to move from B to O, the time taken we should find. That show that, see there are some expressions, square root of A over G, cos inverse 1 over 5 plus 2K. Okay. So, how to get that expression? Now, you see from, it is starting, initial point is from B to O. So, from B to O, what is the time taken? Okay. So, from B to O, what is the time taken? So, how to determine that? In simple harmonic motion, we have two ways. Then we are finding time. One way is they will give you equation like this. X is equal to A sin omega t plus B cos omega t. Using the equation, we should go. Another method we are using is circle method. Okay, so we are going to use the circle method. They give equation only and go through that. Otherwise, normally we use the circle method. So from B to O, total time taken is the question. What you have to show? You have to show that the total time taken is square root of A over G into cos inverse 1 over 5, cos inverse 1 over 5 plus 2K. So how to show this? So how to show this is from B to O, you can split this into two. Directly we can't find. You see, from B to A it is simple harmonic motion because there is a tension. The string didn't get slack. So after passing in the string got slack, then no simple harmonic motion that we call as anti-gravity motion. So this equation is V is equal to U plus 18, V squared is equal to U squared plus 2AS. Those equation we can only use for what? Anti-gravity motion. So for simple harmonic motion, we can't use those equations. And from B to A, we are going to use the circle method and find the time taken in undergoing simple harmonic motion. Then from A to O, we are going to use any of these equations and find the time taken and add both. Then we will get the total time taken to move from what? B to O. So from B to A, how to find the time? Okay. In simple harmonic motion, we are going to use a shortcut to find the time. Now you know, this is the center. Look at here. This is the center of the simple harmonic motion. So amplitude is what? Amplitude is 5A by 2. So this is the center. This is where the velocity is becoming 0. So this is the amplitude. So taking this as my center and the amplitude as my radius, I am going to draw a circle. Then, look at it carefully. From B to A, now I am going to determine the time. Then from A, draw a dotted line like this. This shortcut here. Draw a dotted line like this. Then it is meeting the circle at this particular point. Connect the center at this particular point. That's it. Okay. So the time taken from move from B to A is given by in circular motion this way. Okay. Then how do you find the time? We can calculate the angle turn. Isn't it? Now we know but omega is equal to theta by d. Therefore, time taken is equal to what? Angle turn divided by omega. Now see, now which one we should consider? Now here they are telling cos. That is the answer also. Okay. So cos means this is the angle turn. So you can see this is a right angle triangle. Then we can write sin theta cos theta. So answer is in cos now. So cos means what? Not the opposite side. You have to consider this adjacent side and the hypotenuse. So hypotenuse is what? The radius. See, this is BC. So taking BC as my radius and do the circle. So that is what? 5A by 2. So this particular length is what? 5A by 2. So this particular length we already know A by 2. Therefore we can, if I take this angle as alpha, I can write cos alpha. So cos alpha is equivalent to a by 2 divided by 5a by 2. That is cos alpha is equivalent to 1 over 5. Therefore, alpha is equivalent to cos inverse 1 over 5. Therefore, time taken is equivalent to angle term cos inverse 1 over 5 here into 1 over omega. That is equivalent to square root of 1. A over g. Omega is g over a. Therefore, a over g. So time taken from A to O. How do you calculate time taken from A to O? Okay, we can use V is equal to U plus A. Why did I come to that conclusion? So you see, they are given a K right term right there. And they are given in the bracket where K is equal to what? Root 7 minus root 6. That means that initial velocity minus final velocity. So using that idea, we can tell what? We have used the equation V is equal to U plus AT. So final velocity is what? Square root of 7GA. Initial velocity is square root of 6GA. Acceleration, what you are put? G cos 60. G by 2 into T. Therefore, time taken is equal to square root of 7 minus square root of 6. Okay? Then we have square root of A over G. This is 2 times. That is equal to T. So that is equal to what? T is equal to 2K into square root of A over G. Therefore, we found the time. Therefore, we can write what? Total time is equal to. Total time is equal to. One is this time. So, what is that time? That is cos inverse 1 over 5. Cos inverse 1 over 5 over omega. That is square root of A over G. In this time, also there is square root of A over G common. Therefore, I can take square root of A over G common. Then what will I get? Cos inverse 1 over 5 plus 2K. Okay? So cos inverse 1 over 5 plus 2K. So we show that. Okay. So next one is last part. So last part, what are they asking? Let's say. So last part, what they are asking is when the particle P reaches O, it strikes a smooth barrier fixed at O perpendicular to the plane. The coefficient of restitution between P and the barrier is okay. So what is happening is now it is coming and there is a barrier like this. Can you see here? Yes. So now when it is reaching O, its velocity is what? Square root of 7g. So see there is a barrier like here. So it is coming and hitting it here. And it is going back. So the coefficient of restitution is E. So from impulse and those ideas, you know, if it hits its square root of 7g, it will go with what? E into square root of 7g, returning back velocity. The coefficient of restitution between P and the barrier is E. Show that if 0 less than E less than 1 over root 7, then the subsequent motion of P will not be simple harmonic. Okay. So now you see, now if the particle it is from A to it came also hitting the barrier with the velocity square root of 7g. Then it is returning back, its velocity is E into square root of 7g. So if you show before reaching it, it comes to rest. Then after that, no simple harmonic motion. After reaching O, it is returning with E into square root of 7g. So if it passes A only, again the string will become tight and there will be tension. So there will be simple harmonic motion. So before reaching A, if its velocity becomes 0, then what we can say? The further motion is what? Not simple harmonic motion. Okay, that is the idea. When the particle P reaches O, it strikes a smooth barrier fixed at O perpendicular to the plane. The coefficient of restitution between P and the barrier is E. Show that if 0 less than E less than 1 over root 7, then the subsequent motion of P will not be simple harmonic. Okay, let's see how much distance it is traveling before it is coming to rest. So from O I am applying this equation in this direction. E squared is equal to U squared plus 2x. So what is the distance it will travel when its velocity becomes 0? I'm going to check. Now what is this? E squared into 7g. Okay, 2 into g, not g cos 6. G by 2 into what? Distance I don't know. That only I find. Therefore, 2 get cancelled. So therefore, if I want to find the distance, I should know about this E. Isn't it? You see, from O to A, I am applying V squared is equal to U squared plus 2x. Okay, so I'm planning to find the distance when its velocity will become 0. Okay, so if it is 7 GA in this direction, so what is its velocity? E into square root of 7 GA. If it is hit with V, it will come with what? Bouncing back velocity plus 2 into, here I put a minus, see, because acceleration is this way, G cos 60. Therefore, we are considering this way, therefore minus. Therefore, you will get S is equal to 7 E squared. So I should know some information about E. Otherwise, I can't tell what, whether it comes to rest before A or after A, it is coming to rest. So we know a relationship 0 less than E less than 1 over root 7. Therefore, how can I find it? Is I want our E squared. So I can square it. Then what I will get? 1 over 7. Therefore, when you simplify this, S is equal to what? A. That means when it is reaching point A, it is coming to rest. Therefore, after point A, what? It won't move. Therefore, the subsequent motion, further motion, but won't be simple harmonic. So you can write it in words. It won't be simple harmonic. So thanks for listening. So this is the 2019 SHM.